morning. My third video today is about water chapter according to ICSE syllabus class 8. Okay, in my last video, last video on this chapter, I've started with the introduction and the sources of water, and also the water cycle I've discussed. Now I'll come to the water, which is treated as a compound. We know water is a compound. So initially it was considered to be an element. In 1781, Henry Cavendish, he proved that water is a compound and it is made up of two elements, that is hydrogen and oxygen. This conclusion was supported by Lavoisier. Okay, this this water breaks up into hydrogen and oxygen when it is heated to a temperature of 2000 to 3500 degrees centigrade, or if an electric current is passed through it. Okay, by adding a small amount of acid or amount of a salt to the water mixture. We add a little amount of salt or acid to it, then water dissociates into hydrogen and oxygen when electric current is passed through, or it is a temperature very high temperature, that is 2000 to 3500 degrees centigrade is temperature is given to it, then water dissociates into hydrogen and oxygen. Okay, its chemical composition is hydrogen and oxygen in the ratio of 1:8 by mass or 2:1 by volume. Okay. Then molecular formula is equal to H2O. Chemical name is dihydrogen monoxide. It is known as, chemically it is known as dihydrogen monoxide. When then that equation is given, 2H2O, when electric current is passed through, it becomes 2H2 plus O2. Hydrogen is a non-supporter of burning, but it burns with a pop sound. Okay, if a glowing splinter is taken into the flame, burns in oxygen. Okay, I'm sorry, it burns with a pop sound. If a glowing splinter is taken inside the hydrogen, it will burn with a pop sound. Okay, and if it is but it is a non-supporter of burning. It is combustible gas, but it's a non-supporter of burning. Now pure water okay, I'm sorry, this water dissociates into hydrogen and oxygen. Then hydrogen, we can prove it that it is hydrogen and oxygen. First is, hydrogen will burn with a pop sound, and oxygen, which is coming out, the two gases, if we want to differentiate, first is hydrogen that will burn with a pop sound, and the if a glowing splinter we take inside that another gas, that will burn in the flame, that means into a flame. Okay, that will deduce that the gas is oxygen. First, if there is a pop sound, then we will see that the one of the gas will be hydrogen, and if it the glowing splinter is taken inside the gas jar, then that will show that it will burn into flame, and that will show that the other gas is oxygen. Okay, next is pure physical properties of water. Pure water is colorless, transparent liquid at room temperature. It is a colorless, transparent liquid at room temperature. It is tasteless and odorless, but when the water we drink, that contains some dissolved substances, that's why we feel some taste in the water. Okay, otherwise pure water is tasteless, odorless, colorless, transparent liquid. Okay, now freezing point of pure water is 0 degrees centigrade, and boiling water is 100 degrees centigrade. Pure water, okay, at normal pressure. Therefore, this water remains liquid from temperature 0 to 100 degrees centigrade. Okay, now the boiling point decreases with the decrease in pressure. Okay, and vice versa. If we increase the pressure, boiling point will increase. Okay, that's why when we go up in the hills, okay, when we go up in the hills, the pressure decreases and therefore the boiling point will decrease and it will be very difficult for us to cook. That's why we use pressure cookers in the hilly areas, because the boiling point decreases and the substance which we are cooking, that will uh, not be well cooked. Okay, that's why we need to increase the pressure by a pressure cooker so that the boiling point increases and the substance which we are cooking, that will be cooked properly. And if the boiling point also increases, if we add some impurities inside the water, that will also increase the boiling point. Then this freezing point will also decrease due to the presence of impurities, that is salt, etc. If we add to the water, the freezing point of water will also decrease. Okay, it has high specific heat. Water has a high specific heat value, therefore it needs large amount of heat to become hot and needs more time to lose a large amount of heat to become cold. For this reason it is used as a cooling agent in car engines, nuclear reactors, machines in factories, etc. Okay, for this also the seawater, that the seaside thing, that is the land will cool faster than the seawater. It will gain heat throughout the day, and during the night it will, I mean, it takes time to heat the seawater. It will take the whole long day for heating up the water, and it will, after sunset also, it will not drop the temperature, it will not lose the temperature all of a sudden. It will take the whole long night to lose the temperature of the water. So due to this high specific heat, that is used as a cooling agent, okay, that is used in car engines to cool the engines, the nuclear reactors, machines in the factories they use cooling agent as water. Okay, next is anomalous expansion of water. As a typical behavior of water, when the water, actually we know any liquid which when we decrease the temperature, the density uh, increases. Okay, and when we increase the temperature of a substance, the density will decrease. It will become thin and it will become, the density will decrease. But in case of water, what happens? In case of water, when we heat the water, above 4 degrees centigrade, it will become, rather you can say, in case of water, what happens in the solid form, that is in ice, that is lighter than its liquid. That is what happens, this ice which has less temperature but its density is less. Okay, the density is less, even the temperature of the water is less. That is from 4 to 0, the temperature this is anomalous expansion. Okay, when a substance is heated, it expands, the density increases, vice versa. But in case of water, when it is cooled, it contracts. Okay, when it is cooled, it contracts and its density increases. Okay, but this happens until the temperature reaches 4 degrees centigrade. When it is cooled, this is so because on further cooling, water starts expanding and its density decreases. Okay, when we are cooling the water, till 4 degrees centigrade, the density will increase. Okay, that is according to the normal thing. Normal, when we are cooling, the density will increase. When we are heating, the density will decrease. Okay, that is the thing till 4 degrees centigrade. Beyond, when we cool beyond this 4 degrees centigrade, what happens? The density will decrease and the water starts expanding. Water expands, density decreases on further cooling above 4 degree centigrade, that is below 4 degrees centigrade, below 4 degrees centigrade. When we cool the water, that is 3 2, 1, 0, the temperature decreases. That time what happens? Water expands and its density decreases. And that's why ice can float on water. Okay, the density of water, the density of water is maximum at 4 degrees centigrade. That is, at 4 degrees centigrade, the density of water is 1 gram per centimeter cube or 1 kg per liter. At 0 degrees centigrade, when water freezes to ice, it can float on water because its density has decreased. Density has decreased than the water and the volume has expanded. Okay, due to this phenomena, water, when the lake freezes, the what happens? The ice of the freezing lake that will float on the water above. Okay, and below the freezing lake, the below water that will remain in liquid form, and that will support the life of the fishes. That is, the fishes can remain alive inside the lake even if the upper layer has been frozen. Okay, see, this is the anomalous expansion of water. The above layer that has been frozen, okay, and that acts as a what do you say, acts as a waterproof, proof, air proof. And that will, what will it do? It will even if the further, even if this outside atmosphere cools further, the ice layer will rise, but it will not freeze the whole water body. Okay, the fish can live inside the water very happily because the temperature below the ice layer that will remain normal. Okay, so this is the anomalous behavior of the water. Now we'll start with the water as a universal solvent in my next video. Please go through this. If you have any doubt, please do write in the comment box. And if you have not understood also, you can write it. If you are liking it, press the like button, share with your friends. And if you're not happy with my videos, please do suggest how to improve my videos so that you can be benefited from these videos. Okay, I'm making for you only, so please do suggest how to improve my videos so that you like it much more. Okay, and do subscribe to get the notification of my next video, and that can also produce me encouragements to produce good videos for you so that you can be happy and learn more from these videos. Okay, thank you for watching and have a good day.